Hello, I'm Nitish Pradhan from LabVIEW Programming. It is a sixth video of the LabVIEW signal processing series. Now, in this session, we will discuss about frequency normalizations. Okay, how can we normalize the frequency? So, for the frequency normalizations, okay, in the analog world, a frequency is measured in hertz or cycle per second, right? But the digital system often use digital frequency, which is the ratio between analog frequency and sampling frequency. So that means the digital frequency is equal to analog frequency divided by the sampling frequency. As mentioned in the first line, in the analog world, we measure the frequency in the hertz or cycle per second. How many cycle? Okay. Digital frequency also known as the normalized frequency, and its unit is cycle per second. So in this concept, we'll see, we'll discuss how can we design, how can we generate this normalized frequency. Some of the single signal generation VI used in input frequency, okay, as some of the signal generation VI use an input frequency control F and assume these are the normalized frequency with a unit of cycle per second allowed. So here we'll try to design these concepts. Okay. So for that we need to open our LabVIEW. Now open the LabVIEW to design that normalized frequency, and after that we'll discuss about these normalized frequency concepts. So first of all, we need frequency. After that, take one more control, sampling rate. Okay. Then take one more, that is sample. You can say number of sample. Now, after that last one, we need one enumerate, and this enumerate will contain edit item. Okay. Sample and cycle. Done. Now coming to the block diagram. Coming to the signal processing, signal generation. Now we require signal generation and we'll take sine wave. So how can we get the sine wave? This one, it's sine wave, this sine pattern. So take the sine wave, it's sine wave Vi. This one is the sine waveform. This is sine pattern and this is sine wave. Let's see. Now take one case structure, place here, drag it. Now this one is our sample. Right click here, take a divide functions. In this sample, in this sample, we'll divide our frequency with the number of sample, with the sampling rate, and we'll connect it with the frequency. Now let's convert it into the I32 because sample number of sample will be never a decimal value. So we can convert. We need to convert. Okay. Now come here into the cycle. In the cycle, we'll divide our frequency with the number of sample, and it will be going inside the sign. Okay. So in the sampling, in the condition of sampling, the frequency divided by the sampling rate. Okay. In the cycle, the frequency divided by number of sample. Okay. So now in the both condition, number of sample will be same. Okay. Now let's put one amplitude constant value 1. Right. So this one is frequency type. Set this one. Come into the front panel. Take away from graph. Okay. Now so let's give some. Okay. Now first is sample. So sampling rate will be the 2000. Sampling rate will be 2000. Okay. And the frequency will be 20 and number of sample will be 200. So in this condition, it will plot 200 data. It will plot 200 data here. To plot that 200 data, okay, we will divide this frequency with this 200. So our frequency will be 0.1. Let's see. For that, we need to connect this one with the output. Okay. But if you will change it sample to cycle, so in the sample to cycle frequency will divide with this 2000. So it is a concept of frequency normalization. If you will divide the frequency with the sampling rate, so the the normalized frequency will come out 0.001. That's why it's plotting the 200 data 10 times 0.01. Okay, that's why it's plotting this 200 data is with the 0.01. If you will, sorry, 0.001. No, 0.01. Yes, 0.01. Right, 0.01. If you will divide this one 20 with 200, so your output will be 0.1. So with the duration of 0.1, if you will plot, so with the duration of 0.1, it will plot this two signal. Okay, but if you plot this data, so it will plot you the 10, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20. This 20 sine waveform. Why? Because we are normalizing our frequency. Okay, so if you if you are used to working in the frequency unit of cycle, you can convert cycle to cycle per sample by dividing cycle by the number of sample. Okay, and you can divide your number with the sample value also. So it's a concept of frequency normalization. Thank you for watching this video.